Hello, I am going to talk about probability distributions, discrete random variables, outcomes, and events. So this is a topic in IB Diploma Program, Mathematics, Analysis, and Approaches. This is also a topic if you're taking up statistics and probability. So in Mathematics Guide, so one of the topics under this, is the concept of discrete random variables and their probability distributions, which what I am going to focus on in this video. Alright, so what are random variables? What is it? A random variable represents in number form the possible outcomes which could occur for some random experiment. So let's highlight this one. A random variable is in number form. For example, when you say tossing coins, it is not a random variable, it is a random experiment. But if you are concerned about the number of heads when you are tossing 2 coins, for example, then that becomes a random variable because the number of heads in that event could either be 0, 1, or 2, and they are in number form. Now, a random variable can be classified as being either discrete or continuous depending on the numerical values it assumes. So let's recall the difference between discrete or continuous data. A quick difference will be when you say discrete, it can be counted. Continuous, it can be measured. All right, but a more appropriate definition is this: a discrete random variable may assume either a finite number of values or an infinite sequence of values, while a continuous random variable may assume any numerical value in an interval or collection of intervals. So these are some of the examples of random variables. Let's have the first one. Experiment, tossing 3 coins. So when you toss 3 coins, we can have a possible outcome which is head, tail, tail. So if the random variable is the number of heads, then there is only one number of head in that outcome. You can also have tail, 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 in which in that outcome there is no head. So the value will be 0. So the values of the random variable in this experiment, in this random variable number of heads, will be 0, 1, 2, or 3. And since they can be counted, it's classified as a discrete random variable. Next example is football. If the random variable is the number of goals, then the number of goals could be 0, 1, 2, 3, 4, 5. It can be infinite, right? Or it can be finite, it could also be infinite. So since they can also be counted, it is definitely a discrete random variable. Now what about the last example, data survey? So if we are interested with finding the weight or the weight of grade 12 girls in kilograms, so one could be weighing, let's say, 45 kilograms. So that is a value of a random variable. Now it's within a range because it can also be 45.5 kilograms. So since this data can be measured, it is a continuous variable. Now let's have this example. I took this from a book. For each of the following, identify the random variable being considered, give possible values for the random variable, indicate whether the variable is continuous or discrete. Okay, so I'll give you some time to look at this and then answer the questions. Give yourself some time. Alright, let's try letter A. To measure the rainfall over a 24-hour period in Singapore, the height of water collected in a rain gauge up to 200 millimeters is used. So what is the random variable? So if your answer is the height of water collected, in millimeters, then it is the random variable. Now give possible values for the random variable. So since up to 200 millimeters, so a value could be 150, could be 175, it could be 180 millimeters, it could be 190.5. So since these are being measured, then it is a continuous variable. What about letter C? To check the reliability of a new type of light switch, switches are repeatedly turned off and on until they fail. So let's imagine the experiment. So you keep switching the lights on and off to check the reliability. Okay, so if your answer for a random variable is the reliability of a new type of light switch, it's not right. It's not correct. Because again, random variables should be in number form. But if you are interested with the number of offs, the number of ons, when you're switching it continuously, then it is a random variable. So for example, until it fails, you had to do it, let's say, 50 times. Okay? And then the number of times it went on, let's say, is 45 in 50 times, then it is a value of the random variable. And definitely it is a discrete because you're just counting the number of times it is switching on or the number of times it is switching off. Now let's have this one. A supermarket has 4 checkouts A, B, C, and D. Management checks the weighing devices at each checkout. If a weighing device is accurate, a yes Y is recorded. Otherwise, no N is recorded. The random variable being considered is the number of weighing devices which are accurate. So we are after the number of weighing devices which are accurate, and then that makes it the random variable. So imagine the situation wherein there are 4 checkouts. Okay, checkout A, is it accurate or not? If it is not, then you record it as N. If it is accurate, then you record it as Y. Okay, so in those 4 checkouts, so how many accurate weighing devices are there? So now let's think of the random variable here. What values can X have? If your answer is 1, 2, 3, 4, and even 0, that means 0, 1, 2, 3, 4, then it is correct. Okay, so when you say 0, it means no weighing device is accurate in all of those 4 checkouts. If it's 3, then in those 4 checkouts, there are 3 weighing devices that are accurate. Now, letter B, tabulate the possible outcomes and the corresponding values for X. Now, when we tabulate the possible outcomes, you are now looking at all the possible outcomes. And the tree diagram will help us to come up with the possible outcomes. And this is how it's going to look like. Okay, so, right, checkout A could be a yes or a no. And then checkout B, a yes or a no. Same thing. So that means in total, we will have how many? 16 possible outcomes. So Y is one outcome. Y, N, Y is another outcome. So there will be a total of 16 possible outcomes. Okay? Now another strategy, another method is to list all of them by coming up with a table. Alright, so these are the checkouts. So Y, N. Okay, but of course, looking at the tree diagram will help you visualize, okay, the outcomes. Now, we are after the number of accurate weighing device as our random variable. So if you look at the first outcome, there are 4. The value is 4 because there are 4 yeses here. Okay. Second outcome, now count the number of yeses. We have 3. So 3 is a value of a random variable. All right. Now coming up with this list will help us now to come up with what we call a probability distribution. Probability distribution for a random variable describes how probabilities are distributed over the values of the random variable. All right. Okay, so this is how it will look like. So probability distribution table. So first row will be the values of your random variable, in which in our experiment could be either 0, 1, 2, 3, 4. And to complete this table, we will have the probabilities. So here we have probability of x equals x, probability of the event x being x. So when you say probability of x equals 0, when you go back to this list, so this is 0, but among the 16 we only have 1. Therefore the probability is 1 over 16. Probability of x being equal to 1. So go back to this, we have 1, 2, 3, and 4. That means the probability of x being equal to 1 is 4 over 16. Notice that 2, probability of x being equal to 2, go back to that list, 1, 2, 3, 4, 5, 6, 7. So therefore, probability of x equals 2 is 7 over 16. All right. Now notice that when you get the sum of the probabilities here, 1 over 16 plus 4 over 16 plus 7 over 16 plus 3 over 16 plus 1 over 16 is equal to 16 over 16 is equal to 1. That makes the probability distribution table correct. That makes the probability distribution valid. Okay, so this is the basic of the probability distribution, and this one is just for the discrete probability distribution. So later on, we will continue with the other forms of probability distribution.